Hello students, welcome back to the sixth video of this playlist. So in this video we will try to solve question number 6 from P4 January 2024 paper. So let's see question number 6. Basically question number 6 it's from vectors. The concepts behind this question, it is discussed in vectors chapter of your P4 syllabus. So you can say question number 6 it's from the concepts of chapter number 7 of your P4 textbook. Okay, so let's get started. Okay, question number 6. Relative to an origin O, the lines L1 and L2 are given by the equations. The equation for line L1 it's given, and the equation for line L2 it's also given. Okay, next they says where lambda and mu are scalar parameters. Fine, these are scalar parameters and p is a constant. Okay, so given that L1 and L2 intersect, they are intersecting. Fine. Now part A asks to find the value of P. We need to find out the value for P. So right before the question A, they said what? L1 and L2 intersect. That means we need to use this fact here to answer part A. So if L1 and L2 intersects, what will happen? There will be a point which will lie on both line L1 and L2. That means their I, J and K component will be equal at a single point, right? So we will use this concept. Let's see. So for part A, we will consider what? Since they are intersecting, at the point of intersection there, what? I, J and K component would be what? Equal. So I component for line L1, this is what? 3 plus 2 lambda. 3 plus what? 2 lambda. Okay. And then I, this is the I component. J component is what? P minus 5 lambda. P minus what? 5 lambda. And then the K component is 7 plus 4 lambda. Okay, 7 plus what? 4 lambda. Okay, so this is the vector equation for line L1. Okay, now for line L2, what are the I, J and the K components? 8 plus 4 mu, this will be equal since they are intersecting. 8 plus what? 4 mu. This is the I component. Then J component is what? Negative 2 plus mu. Negative 2 plus what? Plus mu. And then the K component is 5 plus 2 mu. 5 plus what? 2 mu. 5 plus 2 mu. Okay, now we need to solve some simultaneous equations. Okay, so what we can write here? So what we can write? 3 plus what? 3 plus 2 lambda is equal to what? I component, it is equals to what? I component. So 8 plus 4 mu. Okay, now we can write what? Take 4 mu to the left, so you will get 2 lambda minus 4 mu. This is equals to what? This is equals to 8 minus 3, this is 5. Okay, so we can keep it as it is. Don't need to simplify anymore. Keep it as it is. We got one equation, and then let's consider the K components. K components are 7 plus 4 lambda. Okay, would be equals to what? 5 plus what? 2 mu. Okay, so what we can write? Take 2 mu to the left, so we'll get 4 lambda would be 4 lambda minus twice of mu it is equals to 5 minus 7, which is negative 2. Fine. Now what we need to do, we need to solve these two simultaneous equations. So how can we solve this? Let us do one thing. Let us multiply the first equation, the second equation, with negative 2. Okay, so if you do so, what you will get? 2 lambda minus 4 mu. Like I'm using solving simultaneous equation using elimination method. Okay, so if you multiply this equation by negative 2, what it would be? Negative 8 lambda. Okay, it will become plus 4 mu. Then it will be equals to what? Negative 10. Sorry, negative, not negative, it will be plus 4. It will be plus 4. Okay, now we need to add them. So what you will get? 4 mu, negative 4 mu plus 4 mu cancels out, so negative 6 lambda would be equal to what? Would be equal to 9. So we got the value for lambda, that is 9 over negative 6, which is negative 3 over 2. Fine. Now what we need to do, we need to find out the value for mu. The remaining is the value for mu. Okay, so what would be the value for mu? Put the value for lambda in any of the equation. Let us consider this equation. 2 times negative 3 over 2. So 2 cancels out, so this is negative 3. Negative 3, take this negative 3 to the right side, so we'll get 5 plus 3, which is 8. So mu would be 8 over negative 4, that is mu is what? Negative 2. Fine, we got the value for mu. This is negative 2. Now consider what? At the point of intersection, what will be the case? Their j components would be also equal, right? So what we can write now? We can write, look, mu minus 2. Mu is what? Negative 2. So negative 2, negative 2, negative 2, it is equals to what? It is equals to p minus 5 lambda. So p minus 5 times minus 3 over 2, this is plus 15 over 2. Now make p the subject. If you make p the subject, what you will get? You will get the value for p. So make p the subject, what you will get? Negative 4, negative 15 over 2, there is negative 23 over 2, and that's the value for p. Fine, we are done with part A. Next, part B. What they have asked in part B. Find the position vector of the point of intersection. We need to find out the position vector of the point of intersection. That's not a difficult task, since we know the value for the mu and the value for the lambda, so we can easily find the position of the point of intersection, right? So that would be what? The value for mu is negative 2, the value for lambda is negative 3 over 2. So let us like you can put either mu or the lambda, because both have the common what? Points, isn't it? So put lambda, put mu, because this is a integer, this is an integer. So mu is what? Negative 2. So negative 2 times 4, this is what? Negative 8, so that is 0. That would be what? 0. So the I component is what? The I component of the point of intersection is what? 0. The I component of the point of intersection is 0. So we are putting mu equals to what? Mu equals to what? Negative 2 there. So if mu equals to negative 2, then the point becomes what? 0, and then j component is what? Negative 2, this is negative 4, and the k component is what? 5 minus 4, there is just 1. Okay, so we got the point of intersection of the two lines L1 and L2, that is 0, minus 4, and what? 1. They wanted the coordinates. position vector of the point of intersection. That's the value. That's the position vector. Okay. Now next is what? For part B, for part C, what they have asked for, find the acute angle. They asked for the acute angle between what? L1 and L2. Give your answer in degrees to 1 decimal place. Okay. So acute angle. How can you figure out the acute angle? Since they are asking for acute angle, look. If you see line L1, the equation of line L1, lambda times 2i minus 5j plus 4k. What's that? Again you see mu times 4i plus j plus twice of k. What's these vectors represent? These are called the parallel vectors. That means line L1, it is moving, it is parallel to the vector 2i minus 5j plus 4k. And line L2, it is parallel to the direction 4i plus j plus twice of k. So since they are parallel to that direction, so we got their direction. Okay, so we will use these two parallel components, okay, of line L1 and L2 to figure out the angle between them. Okay, so for finding the angles, what we do basically, we consider what? If you consider this is line L1, just for an example, a rough sketch, this is theta, then we can use what? They are getting like this, they are going like this, L1, L2. This is the point of intersection. So we can use the vector dot product. Okay, for vector dot product, what would be the case? Cos theta would be what? Cos theta would be equals to the parallel vector for line L1, that is 2, -5 and what? 2, -5, 4. Okay, 2, -5, 4 dot what? Dot the parallel component for line L2, that is 4, 1, 2. 4, this is 4, 1 and 2. These two vectors are in dot product, and divide modulus of 2, -5, 4, that is what? 4 plus 25, this is 29 plus 16, 29 plus 16, this is 45. So square root of 45, okay, times 4 square is 16, 17, 4, there is square root of 21. Okay, so now figure out the value for theta. So cos theta would be what? Okay, let me simplify it more. Cos theta would be 2 times 4, this is 8 minus 5, again plus 8. Okay, and you will get square root of 45 times 21. This is basically 3 square root of 105. Now just make theta and use your calculator to find out the acute angle. Okay, so cos inverse -5 over 3 square root of 105. So this is basically 99.3607, like that. Is it the answer? No. Why it's not the answer? Because they wanted the acute angle, right? They wanted the acute angle. But if you do cos inverse, you were supposed to get the acute angle. Okay, so 8 minus 5 plus 8, is it correct? 2 times 4, that is 8. Okay, then minus 5 plus 8. Yeah, that's correct. Okay, it was supposed to be what? 16, right? 8 plus 8, this is what? 16 over what? 3 square root of 105. So cos inverse 16 over 3 square root of 105. 5. So what would be the value for theta? You will get an acute angle, that is 58.6 degrees, right? 8 plus 8, 4 times 2, this is what? 8, and 4 times 2, this is what? 8, minus 5, that is 13. 16 minus 5, this is 11. 11 over 3 square root of 105. Then cos inverse answer. So you will get 69, not 59. It would be 69.0 degree. So the value for theta we got 69.0 degrees. They wanted to 1 decimal place, right? 1 decimal place. Okay, so 0 degrees. So that's the answer for part C. Next is part D. For part D, what they have asked, the point A lies on L1 with parameter lambda equals to what? 2. Parameter is lambda equals to 2. Okay. The point B lies on L2 with AB. What? AB perpendicular to L2. Point B lies on L2, right? Since point B lies on L2, we can write the position vector of point B as of the equation of line what? Line L2. That is 8 plus 4 lambda. 8 plus what? 4 lambda. Sorry, 4 mu. Since the scalar parameter is mu for line L2, mu minus 2, and then 2 mu plus 5. 2 mu plus what? Plus 5. Okay, so this is the position vector for point B. Next is point A lies on L1 with parameter lambda equals to 2. So just put lambda equals to 2, you will get the what? You will get the position vector for what? A, right? OA would be what? If lambda is 2, then the value for P we got negative 23 over 2. So that would be 3 plus 4, that is 7. 7, and then what? P is what? Negative 23 over 2. Negative 23 over 2 minus 10. Negative 23 over 2 minus 10. Yes, so this is negative 43 over 2. Negative what? 43 over 2, and its K component is what? 7 minus 8, that is negative 1. Negative 1. Okay, so we got the position vector for point A. Fine. Now what we need to do? 4 times 2, this is what? Oh, lambda is 2. So 4 times 2, this is 8 plus 7, this is 15. This is just 15. Okay. Now what we need to do here is that we need to use the concept from what? We need to use the concept from there. The line AB is perpendicular to L2, right? So which point lies on L2? Point B. Consider just a rough sketch. This is line L2 and this is point B, and here goes line L1. Okay, here goes line L1 and AB. This is B and this is A. Okay, so this line is basically perpendicular, right? So if you consider AB, it won't be perfect. Okay, why it won't be perfect? I will tell you soon. Let's find out at first BA. We will find out BA. So BA would be what? OA minus OB. So OA is what? OA, it's 7 minus 8 minus 𝗴𝗡, okay, then negative 43/2 plus 2, that is what, plus 2, that would be negative 39/2 minus mu, and then 15 minus 5, that is what, 10 minus twice of mu. How I have done it? B to A, it's what, OA, BA equals to what, OA minus OB. So from the coordinates of OA, I subtracted the coordinates of B, okay, and hence I got 7 minus 8, so it would be what, 7 minus 8, this is what, negative 1, negative 4 okay, and then negative mu, negative 39/2, and then 10 minus twice of mu. Now why I have considered the opposite? Why not AB? The reason is that at first try to understand why they have said perpendicular. What's the context for that? What's the reason for that, saying perpendicular to L2? They said perpendicular so that we can use the vector dot product. Make sense? So that we can use a vector dot product, because the vector dot product, says that the two lines has to be getting diverged, right? So the two lines should get diverged like this. That's why I considered B to A, and we will consider the angle between them, that is 90 degree. So cos 90 is 0, so cos 90 will be 0. So in the dot product, as you cross multiply, you will get one side 0. You will have only the dot product, okay. So dot product would be what, BA dot the what, the parallel component of line L2. What's the parallel component of line L2? That is 4, 1, 2, right? That is 4, 1, 2. That would be what? That would be equal to 0, because cos 90 is 0. That's why. So now do the dot product. What will get? Negative 1 and negative 4 mu, okay, then negative mu, negative 39/2, and then 10 minus twice of mu. That would be having dot product with 4, 1, 2, 4, 1, 2, and then the right hand side, it would be what, 0. Fair enough, okay. Now we need to do the dot product. So what you will get, negative 4, negative 16 mu, and then negative mu, negative 39/2 plus 20, this is 10, so 20 minus 4 mu, okay, would be equals to 0. Now take the terms with mu on the other side. What you will get, negative 16 mu, negative 17 mu, negative 4 mu, that is negative 21 mu. So take it to the right, so 21 mu would be equal to what, the constants, negative 4, negative 39/2 plus 20, right? Exactly. So this is negative 7/2. So negative 7/2 divide, okay, we will do the divide later on in the next line. So negative 7/2, and then make mu the subject. You will get the value for mu, that is negative 1/6. we got the value for mu. Fine. So as you get the value for mu, you just substitute the value for mu into the equation of line L2. You will get the coordinates of point B. So we got the value for mu. This is what? Negative 1/6. So position vector of what? B. OB would be what? It would be 8 plus 4 mu, that is 8 minus what? 4/6, right? So this is 22/3i. Fine. Then mu is what? Negative 1/6 negative 2, that is a negative 13/6j, and at last negative 1/3 plus 5, that would be what? Plus 14/3. That would be plus 14/3k, and that's the coordinates, the position vector of point what? Point B. And that's the end of question number 6 from P4 January 2024 paper. Fine.